Hi, everyone. I'm Nunu. I'm from AWS, from the GenAI Innovation Center. We help customers like Zalando to accelerate or kickstart their GenAI journey on their enterprise. 2 years ago, if you thought about asking a computer to generate your slides, that will be almost impossible. But that's what I did here. So I asked Amazon Bedrock to tell me what are the key considerations you should consider to put on a slide to talk about GenAI. So I'll take you on this journey with me in this presentation. But first, let's take a step back, right? And emphasize that all of this would not be possible without the cloud. It's only possible because of all the compute, the data, and the ML size of the models that the cloud enables, right? So this wouldn't be possible to do on-premise. And just in the last 6 years, the amount of compute that we use to train these models has grown 100,000 times. The amount of data we use to train these models has grown 100 times, and the size of these models as well, as a consequence of all of that, has grown thousands of times. This is the first time we can actually train models on internet-size data, right? On models the size of the internet, which is pretty amazing. Just to put it in a little perspective, the amount of words a human would see in their lifetime is about 1 billion words. And these models, they are trained on trillions of words. There's more than 1,000 times what any human would encounter in their lifetime. Just to put it into perspective again, if you think about Wikipedia with terabytes of data, this is thousands of times the size of Wikipedia. So when you build these models with this size, they really start to do some interesting things, right? These foundation models. So why do customers care about this, right? They don't really care about what models we use. The question that they care about is how can they put these models to use in their organization, right? So there's several steps, which is from my first slide. And the first one and most important one is the model, right? What model to choose. And just a couple of years ago, we made Amazon Q generally available. And Q is basically an AI assistant for your company, right? You can chat to your docs, ask questions to your docs, summarize content, generate emails, talk to your code, do code migrations. So it does all of that for you. And the reason I bring Q is that it is an example of an enterprise application. So I will use Q as to show you how you can build your own enterprise applications. Right? So where to start? Obviously, the first place to start is what models to use. And I will use this question as an example. So if you ask the model this question, Model 1 will return a very simple and concise answer, while Model 2 will give you a more complete answer. Which one is better? If you think about it, the answer is always, it depends, right? If you're an ad copy company, maybe you want the first one because it's more concise. If you are a customer service company, then you might want the second one because it's more conversational. You can have a better chat experience, right? But it's still not clear which one is better. So I'll give you another example. What if you ask this question? What is the checked bag policy? Again, Model 1 will tell you a very concise answer that maybe is good enough. And Model 2 will tell you a more complete answer. Model 1 is fast to respond, and Model 2 takes about 10 times more time to respond. It needs 10 times more compute, and by consequence is 10 times more expensive. Do you really need this type of power for such a simple answer? Again, it depends, so it's still not clear. And when we're trying Q and other GenAI models, and I'm sure when you try models you'll encounter these problems as well, which model is better? Which model to select, and what criteria to utilize to compare the models in the first place? And there are potentially dozens of metrics you can use. I just put here 5 on this slide to start the conversation. So obviously the first one is cost. You want something that is cheap. Also, how complete are the models? How complete are the answers? Does it cover everything that you need? How often does it come up with things that doesn't exist? How often does it hallucinate? How concise are the answers? Do you want concise answers in your use case? And how fast, how low latency are these models, right? So let's look at some results according to this criterion. So if we have the two models, the first model you can see is not as cost effective, but is a lot more complete, right? So depending on your application, you can start seeing some models are better for some things, some models are better for some other things. If we have even more choice, right? Having more choice helps you because you can really choose the one for your application, but actually you cannot still answer the question, which model is better? So the recommendation here is to pick one model that is good for your application. In this case, I picked cost effectiveness, right? And then you optimize the rest of your application to make it work. You optimize it for hallucinations, you optimize it for completeness, etc. But you need to pick one to start with. Right? So what kind of optimizations can you do? Initially, we thought we were going to use always the best model, right? Why not choose always the best model? But then we end up in a very different place because different models are good for different things, and obviously cost matters, right? So we'll get into the first part of our story, which is the models. What models to use? When you think about a Gen AI application, right? Some models are good for intent detection. Some models are good for summarization. Some models are good to gather documents, and some others to actually formulate your answer, right? So there's no one model to rule them all. Each model is specialized into one or two things, right? And this is not intuitive. We always thought, OK, let's always use the best model. So we might think this is not intuitive to you as well. But if you think about it from the way our brain works, right? You have the frontal cortex, who focuses on certain tasks like reasoning, and you have the limbic system, who focuses on fast, quick responses, right? Even if you study the brain neurologically, it's built different. These different parts of the brain are built different. It's like different models in generative AI. So what other optimizations did we do after we looked at the models? Obviously, data. We spend a lot of time with data engineering. Without data, you cannot do anything. So let's use this question to explain why data is important. If I ask a model to tell me about my customer meeting for tomorrow, it needs to speak to a few data systems in my company to make that work. Right? It needs to check the calendar. It needs to check the CRM to get information about the customer. It needs to get other company information and put all of that together, aggregate all of that, and give that to the large language model to get the final answer, right? So besides the models, data is super important. Having all of those connectors to make it all come together. So you have models, you have data. Are we done? Not nearly done. One thing that's super important for AWS and should be important for you as well is, for example, when you have this type of question, right? How do you think we should answer to this question? So a software engineer wouldn't have access to this type of sensitive information, right? But the CEO of the company should have access to this information. So you should have access controls to control who has access to your data. And this is just one of the areas of responsible AI, right? There are many, many others, like restricting sensitive topics, reducing hallucinations, blocking certain sensitive keywords. All super important. So you have models, data, responsible AI. We're not there. If you remember our first slide, we had 5, right? So what's missing? Obviously, having a low cost and performant architecture and infrastructure, right? Without that, if your answers take 2 minutes to respond to your customers, they won't be happy. So you need all of this to get to your Gen AI application, right? So you can only have your Gen AI application when you have all of these 5. And when you're building a GenAI application, sometimes you want the control, right? So you want to run your own endpoints on SageMaker. Some other times you just want to call an API, right, that orchestrates all of this for you. So everything is possible. So let's dive deep into each of them. We saw that having an easy way to choose different models that are suited for each part of your application is super important, right? That's why we build Amazon Bedrock. Amazon Bedrock is the easiest way to build GenAI applications in a private and secure way. It's just an API call that takes care of everything for you in the background, right? So it gives you the choice of the models. You can customize models. Just because it's an API, you can still fine-tune your models. You can still do retrieval augmented generation. You can also use agents to call other internal APIs. For example, if you're in a financial institution and you want to use a chatbot to do bank transfers, you could use agents to call those internal APIs. Obviously, with security and privacy built in and responsible AI. As we mentioned, some models are better than others for certain tasks, right? Some models are really fast, some others are really complete, and you want to choose the best one for each part of your application. That's why on Amazon Bedrock, we provide this wide choice of models. So every week, a new model is coming, is launched by either proprietary or in the open source community, and very likely it will be in Bedrock, right? So you have this choice. You're not locked in to a specific model, as new models becoming obsolete very quickly. We also talked about how data is a big differentiator, right? So at AWS, we provide the most comprehensive set of data services, from integration, data ingestion, SQL and analysis, and then also from the cataloging and governance side. You can do it all end-to-end. As we saw that data is super important for any application, especially for generative AI. As I mentioned, it's also super important to have responsible AI from the ground up, right? So there's a couple of different ways that we do generative AI. One is, obviously, Bedrock has responsible AI built in from the ground up, right? So that means your data will never be used to train the foundation models, either Amazon models or third-party models, right? So those providers will never see your data. That always stays within your account. And data is always encrypted in transit and in rest. And it's also, the models you fine-tune will never leave your VPC. So that's what we do from the ground up, but also that is not enough for many applications, so you need to put some guardrails on top, right? So that means you want to do some filtering, you want to prevent chatting about certain topics that may be sensitive, and you want to reduce hallucinations. Again, this is not possible without a low-cost and performance infrastructure, and there's several ways you can do it as well. You can use your own GPUs, accessing your own compute choice. But also, if you're doing something more complex, like training your foundation models or fine-tuning, you have access to a couple of purpose-built accelerators, one for inferencia, it's about 40% better, and the other for training, called Trainium, that is up to 50% faster when you're training your own foundation models. If you're actually training your own foundation models, you can also accelerate it using HyperPods, which is something that was launched a few months ago and is now generally available as well. So finally, we got to the application stage. Once we have all these building blocks, our AI generated this slide for us. And who better than to speak about an application, actually, one of our customers that we worked with. So please welcome to the stage Wei Wei from Zalando.
Thank you, Nuno. It's great to be here. My name is Wei Wei Chen. I'm a senior principal scientist at Zalando. Zalando is a publicly traded German online platform specializing in fashion and lifestyle goods. With presence across 25 European markets, we have around 50 million active customers. On our website, it features products from thousands of different brands. For the customer visiting us every day, millions of them, either is browsing the latest fashion trend or picking up something specific, presenting them informative and accurate product information is critical. Often, we present a set of diverse products to them, ranked to meet their expectations. On the product page, each product has a set of images as well as a set of product details. They help the customer understand how the garment will fit, what is the material, and the care instructions. All this information is there to help the customer find exactly what they want. All this is not possible without correct product data, which is extensively applied under the hood. When products arrive at Zalando, it comes with raw description from the vendors and brands. We would take these raw descriptions and parse them into product metadata. There are a set of key value pairs that define the product using the internal taxonomy of Zalando. Because the product metadata is region agnostic, it allows us to easily localize the product for our customer in different countries. The product description comes in all kinds and flavors. It is limited only by the provider's preferences. They can differ significantly in terms of language, the data format, and even the terminology used for the same attributes. Conventionally, we have a process, a rule-based system to extract the product metadata from the product descriptions. And that requires quite a bit of manual inspections. This process has its limitations. It is constrained by human capability, and also it varies a lot in terms of the quality on the language, the data format, and the difference in terminologies. In order to automate this process, we have been collaborating closely with Nuno's team and utilizing the GenAI services from Amazon. For our use case, Amazon Bedrock is a great fit. Large language model contains the common knowledge and can operate across many different languages. So in our case, the task becomes to align a model from Amazon Bedrock and make it tailored to the requirement of Zalando. A properly designed system should be able to automate this process and allow Zalando to extract more product metadata with a high quality. There are many, many strong reasons why we want to have better product metadata. For example, enhanced product metadata can make the search better. It allows us to define fine-grained search criteria and filters. The customer can purchase faster because now they can find the product faster. And all of this leads to an overall improvement for the shopping experience. Additionally, enhanced product metadata also open the possibilities for advanced personalization. Technologies such as personalized size recommendation rely critically on the size and the fit data of the garment. There is a common practice where customer would buy multiple different sizes return all of them but one. But with technology of the personalized size recommendation, this practice can be outdated. For Zalando, it also means lower return rate, less packaging, faster delivery, and overall lower cost. Apparently, the enhanced product metadata is super beneficial for both the customer and the company. So how do we do it? In order to transform the raw product description to product metadata, we utilize the large language model from Amazon Bedrock. We would construct prompt that including the product description alongside with some helpful instructions, so then the LLM can extract the product metadata. We have a post-processing function to make sure the extracted data is consistent with the format we used internally at Zalando. In our approach, we have a unique prompt for each product. Products can belong to different categories. There are shoes, there are shirt, there are dress. The task of the LLM is to assign the attribute of the category that product belongs to. For example, shirt has the sleeve length attribute, and the shoes has the heel foam attribute. Each prompt only needs to contain the minimum required information. It is sufficient to have a configuration file that contains the taxonomy of the category and some examples. We then have a script to come up with the prompt and the post-processing filter function allowing us to effectively extract the product meta for the product in that category. When we switch from product in one category to another, the overall extraction pipeline stays the same. Only the category-specific parameter needs to be changed. So, we construct a prompt to describe the task to the large language model. We provide a list of admissible values in the output. We also demonstrate several examples of successfully passed product descriptions. In the machine learning literature, it is called few-shot prompting. Additionally, it will generate a filter function to make sure in the outcome there's no irrelevant attribute or values. This solution allows us to extract more product metadata faster. It outperforms the existing system in terms of the accuracy. This solution is also very robust with respect to the language, the data format, and also the terminology used. Because now we have enhanced product metadata, it leads to a global improvement. We now have better product descriptions, have a better search. It also allows us to design advanced personalization techniques. By helping the customer buying the stuff they exactly want, it also reduces the return rate for Zalando. And with that, I'm heading back to Nuno. Thank you.
Thanks, Weiwei. That was great to see customers like you building their Gen AI applications on Bedrock. So just to finalize, we reviewed the key characteristics that are important to build a Gen AI application, starting with an easy way to choose the models, to your data, where the value is, doing it responsibly from the ground up, having a low cost and performant architecture and infrastructure, enabling building Gen AI applications. All right. So if you can build your Gen AI application just by calling a few APIs or going as complex and fine-tuning your own model, everything is possible on AWS. We've done it. Now you can also do it. This is how you can learn. Feel free. I'll give you a few seconds to take a screenshot of that. You can join millions online in training, attend courses, and then even get your own certification for those of you who are interested. So thank you for your attention. It's been a pleasure speaking to you, and please enjoy the rest of the Berlin Summit. Thank you.